Welcome back, everyone. Now we have Matt from Google to talk with us about choreography versus orchestration in serverless microservice. Very welcome, Matt. How are you?
I'm very well. Thanks very much.
Okay, so you know the drill. If you have questions for Matt, please ask them on Umbrella. I know Matt is on Umbrella as well, and you can answer a question directly, or I can relay the questions myself if by chance Matt misses them. So thank you again, Matt, for being with us. You are very welcome to Portec Hub, and please introduce yourself and the stage is yours.
Great. Thanks very much for the introduction. And hello, everyone. My name is Mete Atamel. I am a developer advocate at Google. I'm based in London, so same time zone as Porto, I guess. But as I told to the host before, like probably much worse weather. It's cloudy today, but no rain at least. So today I want to talk to you about choreography versus orchestration. So it's about how do you organize services. And here I mentioned serverless microservices, but it doesn't have to be serverless, and it doesn't even have to be microservices. We can think of this as services in general. My slides are already on speaker deck. On speaker deck. So if you go to this link, you can grab the slides. And I'm watching the chat. So if you have any questions, feel free to ask as we go along, and I'll try to answer them as we go along in the presentation. But we'll hopefully have some time in the end as well. All right. So how are we going to do this talk? First, I want to explain to you what I mean by choreography orchestration, what are the pros and cons of each approach, and when should you use one or the other. Then I want to look into the landscape and talk about some of the tools that help with choreography and orchestration. Then I want to zoom into orchestration and talk about Google Cloud's orchestration service called Workflows. And the point there is to let you know what you can expect from an orchestration service. What are the things that are given to you? And then finally, we'll finish up with a case study, an application that we initially wrote using choreography, and then we rewrote it using orchestration and what we learned along the way. To be honest, I think the last part of the talk is the best part because it's based on real experience, and it's also has some good lessons. So hopefully I will lay the groundwork for the case study so you understand the landscape that we're in. And then in the actual case study, you'll actually see the orchestration in play and how it helped for us. All right, so let's get started. What do I mean by choreography and orchestration? Well, let's try to answer this question with a simple e-commerce transaction. Let's imagine that you're trying to build an e-commerce application. And as you know, in e-commerce, you want to sell things. So you usually receive orders, then you authorize and charge credit cards, and then you prepare and ship items, and then you notify the users about the progress, right? So one way of kind of modeling this is you could have services for each main steps in your transaction. So a front end to receive the requests, a service to process the payment, another function or a service to ship the items, and maybe another service to notify the user. Of course, I understand in real world e-commerce, things are much more complicated, but I'm just trying to simplify this to make my points. So you can have these microservices laid out, and you can have each microservice call the next microservice in the chain. So the front end calls the payment processor calls the shipper, so on and so forth. So this simple REST-based approach, right? What are the pros and cons of this approach? Well, first of all, you have microservices, right? You are dealing with small services that do small things at a time, not a single monolithic applications where you deploy everything together, right? We learned that a single monolithic application is not the way to go for many reasons that I won't get into here. It's much better to deal with smaller services that can be deployed and scaled independently, that can be debugged easier, things like that. So we're in the right path by going with a microservice kind of architecture. And these microservices, they call the next service in the chain. So all a service needs to worry about is, do my work and call the next service in the chain. So it's easy to implement. And conceptually, it's easy to understand. It's not a complicated kind of architecture. Now, on the other hand, now each service needs to know what the next service in the chain. So there's coupling between services. And this is not great because now whenever you need to update a service, you need to think about what am I calling next and what am I calling and who's calling me before, right? So that this coupling could introduce problems. You can't just focus on your service. You need to focus, if you change anything about the service inputs and outputs, it potentially could affect the service before or after. And that's not great. Each service could be a single point of failure. So if the payment processor fails, then the whole transaction fails. That's not great. For things not to fail, you probably want to have some kind of error handling, retry logic, or timeout kind of logic. So that logic has to be implemented in each microservice, right? It's extra work that you need to think about. And the whole transaction there's nobody watching whether the transaction is successful or not, right? I mean, each microservice could do its own part, but things could still go wrong, and you need to think about the transaction as a whole and figure out what you need to do if something goes wrong. Now, you can take a different approach, also known as choreography, and choreography is also known as event-driven, by the way. And in this model, each service just receives and sends events. So front end receives a request, and it says, okay, I received a request, and it creates a new order message, and it sends to a message broker that handles the messages. Then this new order message will be picked up by a payment processor, and that will receive the message and then do its part, and then it will emit another message type, payment processed, right? So you can see that in this model, the services there, they don't know about each other. They don't care about each other. They don't communicate directly with each other. They communicate indirectly through different message types. And all you need to do for this choreography model is that you have a messaging backbone that receives the messages, and you have rules in place to route the messages to the services who care about those messages. Now, what does this do for us? Well, first of all, your services are loosely coupled. They don't have to care about the next service in the chain. And that's a really good thing. Now, because when we went from monolithic applications to microservices, we broke down our monolith into independent services, but we lose that independence if they're tightly coupled, right? But event-driven systems, they give you that independence back. Now, the services, they don't need to care about each other. They can just do their own thing, emit their messages, and that's it. Each service can be scaled and chained independently. So we are living the promise of microservices. There is no single point of failure in the sense that if a service doesn't respond to messages, then the rest of the services that could respond to that message, they will respond to it. Now, this doesn't mean that the transaction is still complete. Things won't work 100%, but maybe in some cases, a partial working state is still okay for your system. And events are really useful if you want to extend your system. So let's say you want to add a new service in your architecture. All you need to do is deploy the service, figure out what kind of messages it's interested in and what kind of messages it might emit. And that's it, right? You don't need to worry so much else, like other services or anything like that. So this makes it really easy to extend your system. On the other hand, once you go from services calling each other to an event-driven kind of system, it becomes hard to monitor your system. If something fails, it's not so obvious what failed. When a request comes in, you probably have a correlation ID, and you try to track that correlation ID through different events, but it won't be so easy to see where things failed. You will always have to kind of hunt down and see where the correlation broke, and look at the service, look at the logs, and try to figure out where things failed. So things become a little bit more difficult to monitor. The errors, the retries, and timeouts, you still need to worry about them. They don't go away. And the business flow, the way things are supposed to flow in your system, that you kind of lose that information. In our simple scenario, we had 3 services calling each other or 4 services calling each other. So that was the flow. But when you take these services and make them event-driven, they're kind of like living in a state that you cannot visualize. Like a business flow is not so obvious anymore. You just have messages flying around, but how do they flow from which service? You kind of lose that information a little bit. And this whole problem of the transaction being successful or not, how do you ensure that? that's still a problem that you need to deal with, right? And imagine a more complex transaction. I mean, this is probably a more real world kind of transaction where you read certain things from a database, then you, depending on certain condition, you take different branches. This transaction, when you look at it, it's easy to understand because it's a flow chart. So business flow is very defined. But taking this and converting into an event-driven architecture, it is possible, but then you kind of lose this flow chart. In the end, you won't be able to visualize this from your architecture anymore. So you're losing that information. It's not that great. So what can you do? You can take another approach called orchestration. And the idea with orchestration is that here you can have an external service, an orchestrator, that can direct the calls to your services. So the front end still receives the requests, and then it will kick off an orchestration in the orchestrator, an external service, well, external to your microservices, I mean, but they're all in the cloud in this case. The orchestrator will have rules that define how to call the services in what order. So first, in this case, the orchestrator will call the payment processor, and it will get the result back. Then it will pass that result to the shipper, and then it will get the result back, and so on and so forth. So the orchestrator can do this because it has the rules. It can do the passing the variables between different steps, and it can also do things on errors. Like if something fails here, for example, in payment processor, it can do retries, or it can do error handling, things like that, right? So what are the pros and cons of this orchestration approach? First of all, you can now capture the business flow of your application, because in Orchestrator, there's a way to define the orchestration. And in that orchestration, you define how things are supposed to flow. And because you can define it, you can source control it. And because you can source control it, you can version it, right? So, and this is very useful because you can point to people, basically, this is my flow, how it's supposed to work. And you can, if there's something wrong, create a new version it, check it again, and you can capture the kind of the progression of your architecture. And you can visualize it too. And I'm going to show this when we talk about the case study, but this is very useful for many reasons. Each step can be monitored. So if something fails, you know which step failed in the orchestrator, and you can zoom into that step right away. So monitoring becomes easier. Errors, retries, and timeouts, you still need to do them, but you can do them as part of your orchestration. The orchestrator can do this for you, so you don't have to implement them in each microservice. So that means less code in your microservices and more centralized logic. And services are still independent, right? They're still deployed independently. They can be scaled independently, but you're kind of putting them together into an orchestration. It's kind of like a temporary monolithic application in a way, right? You're kind of bringing them together temporarily, but the services are still independent. So you get the best of both worlds. The best features of microservices, but also the coupling that you get with orchestration. Now, on the other hand, an orchestration service is something to learn and maintain. It's a different way of architecting your applications that you might be used to. It could be a single point of failure, because if your orchestrator is not a resilient and redundant kind of service, if it fails, your whole transaction still fails. So you need to keep that in mind. It's not going to solve all your problems, especially if you don't use a good orchestrator. And you're going to lose some eventing flexibility. So if you need to introduce a new service, now you need to deploy the service, but you also need to change your orchestration rules and include the service into your orchestration and deploy your orchestration again. So changing your architecture becomes more involved now. Now, in terms of the whole transaction, you will probably have easier time to detect errors in your transaction. So if something goes wrong, you can probably detect it much easier in orchestration, but you still need to take action. For example, let's say you charge the user, you charge the user's credit card, and then you go to the next step to ship the item, right? And if the shipping the item fails, you can retry and all that kind of stuff within the orchestration. But if it still fails, then you need to take steps to undo the transaction probably, right? So you need to have compensation steps. And that is not free. Like, you need to think about it and you need to implement it in your orchestration. So transaction becomes more reliable, in my opinion. But at the same time, you need to worry about how do you compensate for failed steps? So what do we do? Like, which one is better, choreography or orchestration? And the answer, as in every software engineering or architecture question, is it depends. But I think in general, if your services are not closely related and they can exist in different contexts, then it's usually better to think an event-driven kind of way, architecture, because that will allow you to plug in your services easier in different architectures. But at the same time, if your services are always closely related, they always are deployed together, they always go in a certain order, then maybe you don't need the flexibility of eventing. You might as well go with orchestration because they're always, called in a certain order. Also, if you have the business logic, like the flowchart that I showed you, and you want to kind of capture that and maintain that, then orchestration allows you to do that. Whereas, taking that and changing to event-driven, you kind of lose that information. So these are kind of the main things I look for when I'm trying to think of the architecture. Of course, you don't have to choose. You can also combine the two. So for things that make sense to be orchestrated, you can put them in an orchestration. And then maybe at the end of that orchestration, you can signal other orchestrations using eventing, right? And actually, this hybrid approach is what I see mostly. It's not one or the other, but it's actually a combination of event-driven orchestration. So maybe this orchestration gets triggered by an event, then it does something. Then if it needs to do more things, maybe it signals to other orchestrations using messaging. So it's really up to you and what you're trying to do in your architecture. All right, so that was a really quick introduction to orchestration and choreography. Before we look at the landscape, let me see if there's a question. And I see someone asking, no, I don't see any questions. There's some comments from people, but yeah, feel free to ask any questions if you have it in the chat. So in terms of landscape, what kind of tools and services we have in this area? Well, first of all, event-driven systems, they've been around for a long time. And whether you're running on AWS or Azure or Google Cloud, you have services, multiple services to help you with that. And if you are in open source, you can use things like Kafka or RabbitMQ. So what I mean here is that event-driven architectures have been around for a while, and there's a lot of tools and services and open source projects to help you in there. So don't try to build your own system. It's not worth it. Instead, try to learn one of the systems and use them. Now, in terms of orchestration, the choice is a little bit more limited. So AWS has step functions, Azure has logic apps, Google Cloud has workflows. Then there's open source projects like Apache Airflow for application and data orchestration. And also Cloud Composer is the managed version of the Google Cloud. So the choice is more limited, but there's still choice on each cloud. And there's also open source projects like Apache Airflow. And I actually did a little comparison between step functions, logic app, and workflows just to see how they compare. I won't go through this table in detail, but what I want to point out is that all the basic features of these services, like AWS step functions, Azure logic apps, or workflows, you have them in each cloud, basically. So the basics are there, no matter where you're running in the cloud. But when you go to more advanced features, it feels like the step functions, they are more geared towards orchestrating AWS Lambda and AWS services, whereas logic apps and workflows, they are more geared towards orchestrating pretty much anything you want to orchestrate, right? So I see some things missing in step functions. Logic apps seems to have the most features and most mature, at least last time I checked a few months ago. But workflows is also coming up with some features that are catching up with logic apps. And of course, if you're not in the cloud and you still want to do orchestration, you can do orchestration yourself. So you can try to build that yourself. But there's also an open source project called Serverless Workflow from CNCF that's trying to create a vendor neutral open source specification, SDKs and runtimes and tooling around workflows. So this whole idea of application workflow is gaining momentum in the open source as well. And I'm hoping that this open source project will give us more tools that we can use anywhere, not just in the cloud. All right, so that was a quick summary of the landscape. Now I want to zoom into workflows, Google Cloud's orchestration service, and let you know what kind of tools that or features it provides you to make orchestration easier. And then after that, we'll look at our demo application and also lessons learned from that case study. So workflows, it's a service from Google Cloud to orchestrate and integrate. It allows you to integrate Google Cloud, your code basically running in Google Cloud. It doesn't have to be serverless, by the way. It can be on any code basically that you have running on Google Cloud. As long as it's publicly accessible, it can be included in your workflows. You can orchestrate Google APIs. So any Google Cloud API, like Vision API or BigQuery or anything like that, or any Google API like Gmail, Hangouts, that's publicly accessible, can be included in your orchestration. And then your external APIs as well. So if you want to call like an external API like Twilio API or SendGrid or anything that's publicly available, you can include those in your orchestration as well. Now, in terms of how you define your orchestration, there's a workflows definition language that's defined in YAML or JSON. And here I'm showing an example of a YAML. So in our simple example, we had payment processor calling shipper, calling notifier. So if you want workflows to call them in this order, you define 3 steps: process payment, ship items, notify user. These names, you choose what you want them to be. Then you define what happens in each step. So here we are saying we are making an HTTP post call with this URL, and this is the input to that URL. And you can say that this input comes from as a parameter, so it's passed into our step, right? The workflow will make this call, and it will capture the result in process result. So that's the variable that we are using to capture the result. Then we go to the next step. We call a function this time, and we pass in the body of the result as input to it. So you can see how we are defining steps, how we're making HTTP calls, and how we are capturing the result in variables and kind of parsing them a little bit to get what we want. So that's step sequencing. You can do things like serverless pause, where if you want to wait a little bit between shipping and notifying the user, you can add a wait in your step. And as I mentioned, you can pass variables between steps, and you can parse the results before you pass them on. So that kind of stuff becomes really easy with workflows. Now, in terms of errors and retries, in each step, you can define how many times you want to call that step. So let's say the payment processor is flaky, and you want to call it 5 times and back off in an exponential back off kind of way. You can define that policy as part of your step call, okay? And this is useful too if you want to implement some kind of global error policy and retry policy. Or you want to maybe sometimes do different things depending on the outcome. So you call the shipper function that returns a success error code, HTTP. You want to branch to a different service, or if it's an error kind of code, you want to branch into another service. So that kind of stuff can be part of your orchestration. And conditionals. So let's say you read some value from a database, you check if something is in stock or out of stock. And then you want to do different things depending on that, maybe call third-party APIs. So all this kind of stuff that you usually do within your code, you can do it within the orchestrator. So that allows you to kind of get rid of this logic kind of things from your code and put them in orchestration and do the business things within your code. And you can take workflows and create sub-workflows out of them. That way you can reuse them from different workflows. You can use connectors to connect to Google Cloud Services. So this helps because you don't have to create the HTTP request with all the details yourself. Instead, you can use a connector, and that makes it easier. And finally, there are features like iterations. For example, let's say you want to read something from Twitter, get 1,000 results back, and iterate on those results, right? In a for loop. That can be done in workflows. Or if you want to include a human in the loop. So let's say you have some steps that run, and at some point you want that step to wait for a human to say yes or no. You can introduce callbacks, and the human can call that URL, and your step can wait for the callback, and it will continue. This is a preview feature, but it's going to be GA soon. And to deploy a workflow, you define your YAML and deploy. So this updates your workflow, but it doesn't run it. To execute it, you just run execute. And to see the result, you describe it, and then you see what happened with your workflow. Of course, all of this can be done from the UI. So if you go to Google Cloud Console, you can see the source. You can define the workflow here. You can see the visualization of workflow here. You can execute it and all that kind of stuff. And I will show you this when I show you the application. And by the way, you can see how nice this is, that you define the workflow here and you can visualize it. So your business flow, the flow or your architecture is very visible here. And that helps a lot when you're running things in production. All right, so that was a really quick summary of workflows. Now I want to talk to you about a case study, a picture sharing application that we built initially using orchestration, and then we rewrote it using, initially using choreography, and then we rewrote it using orchestration, right? So first it was event-driven, and then we rewrote it using workflows. And I want to go through that and explain to you what kind of things we learned along the way. But let me just double check if we have any questions. Doesn't seem like we have any questions. Okay, so let me talk about this app. So this application is called Pic-a-daily. It's a picture sharing app that was built for a customer in London to showcase our serverless features. So that's why it's called Pic-a-daily, because we wanted to combine the Pic-a-daily circus in London with picture sharing. So that's Pic-a-daily. And it's actually part of a workshop. So if you go to this link, and I'm going to share this link at the end as well, you can build this app yourself and see how it works if you like. And what this app does, and let me show you this app actually. So I have it here running. And by the way, this is the workshop. And in this workshop, we show you how to build the event-driven application in first 5 labs. And in the 6th lab, we show you how to forget about all of that and build it using orchestration. So you have the whole picture, either event-driven or orchestration. And the code is on GitHub as well. So this is the code GitHub link that I'm going to share at the end. So feel free to check it out if you like. But in this app, you first upload pictures. So you go to an upload page, you choose a file and submit it. And then what we do is that you can see in each picture uploaded, you see labels. Well, first we detect if the picture is a safe picture, because we don't want people to send any kind of pictures. So we detect if it's safe. And then we, using machine learning, then we extract the labels out of this picture. So you can see this picture has water, cloud, sky. These labels come from machine learning as well, using Vision API. And you can see that there's a border around this picture. This is a dominant color in this picture. We extracted using machine learning as well. So you can see that user uploads the picture. We analyze the picture, produce the labels, produce the frame around it. And we also create a collage of these 4 most recent pictures. So the 4 most recent pictures uploaded, we put them together into a collage, right? So it's a simple app. And the way we built this initially was this way. So this was the initial architecture, event-driven choreography architecture. And now in this architecture, we have a front end on App Engine. Users upload the picture. This goes to a cloud storage bucket. This is a place where cloud storage it's a service to save any kind of files. Then we, once the image goes to this bucket, it fires off a number of different event types. The first event goes to a cloud function, and it's a direct event from storage to cloud function. Then the cloud function analyzes the picture using Vision API, then stores the metadata, the labels, the colors, and things like that into Firestore, which is a NoSQL database. Then the second event goes to a Cloud Run service, which is a container service. It runs containers. And you see that this is no direct connection, it goes through PubSub. And the reason for this is that there's no direct connection from storage to Cloud Run. Instead, we had to go through PubSub. you can see that depending on which kind of service you want to use, you're dealing with different events, right? So this is a direct event. This is a PubSub event. So we get the file event through PubSub to Cloud Run service, and this service looks at the image and creates a smaller version of the image. So it takes the image and creates a smaller image and saves it back. A third service called collage service runs on a timer. So this Cloud Scheduler calls this service. It will go and figure out 4 most recent pictures from Firestore. It will fetch them and it will create the collage and save it back. And finally, the image garbage collection service is the last service that receives an event when an image is deleted. Okay, when an image is deleted, it will receive it through EventArc, another service on Google Cloud for eventing, and it will go and delete the thumbnail of the image, and it will also delete the metadata of the image. Now you can see here that everything is event-driven. The services are loosely coupled, which is great. And services don't know about each other. That's also good. But at the same time, what we were running into is that, first of all, we were running into different eventing formats. There was this event that was a direct event to the Cloud Function. There was this event that was going through PubSub, scheduling event. There's event from EventArc. And all of these events, they had their own formats. And it was getting a little bit complicated, even with 4 services, 5 services, with 3, 4 different eventing formats. You had to really change your code and kind of parse things differently when you're dealing with different eventing formats. But that's just the reality of events in general. Depending on where you're getting the events, you might have to deal with this. And secondly, when something didn't work, like for example, when we uploaded a picture and we didn't see the picture, we didn't know where things failed. It wasn't obvious. We had to kind of track things with IDs and everything, and then see which service it could fail and just look at the logs of the service. So it wasn't really that immediately we could say, okay, this service is not working, right? So in a small architecture like this, it's not a big problem, but you can imagine in a big application with tens or maybe hundreds of services, this can become a real issue, how to track these errors. So, and also when you think about this is event-driven and it's all great and all, but at the same time, the way things should happen in our application was very kind of it was very obvious what should happen in what order, right? So when the user uploads the picture, first we want to analyze it. So that's the first thing that should happen. Then once the analysis is done, then we probably want to create a thumbnail out of it, right? So once we have the thumbnail, then we want to create the collage out of it. Then if it's a deletion event, then we want to do the garbage collection, right? So even though we are using events and they're all loosely coupled and they all run in parallel, we didn't really need that flexibility. Instead, we wanted things to happen in a certain order. So that's when we started. And by the way, this is the 3 different eventing formats I mentioned, and it has real implications in your code. You can see that in the first one, we are getting the event directly. So the event is very nice and clean. In the second one, in Cloud Run, we are getting it through PubSub. So we have to get the PubSub message, then look at the data field of the PubSub message, which is base64 encoded. So decode that, and then we'll get the file event. And then in the third one, it's the Cloud Run service through EventArc. We are getting another event type called Cloud event. So we need to get the Cloud event, which has the file event wrapped into an audit log. So we had to get the audit log, then we get the file event. So you can see that it has real implications, and you need to keep track of these things, like what's the event type, how do I parse it, things like that. So what we did is that at the beginning of the year, when workflows became GA, we said to ourselves, okay, why don't we take this and try to rewrite it using workflows and see how that looks like. And this is what we came up with. And when you look at this initially, you're probably thinking that this looks more complicated than it is. But actually, everything in these red boxes, it's one service. It's a workflow service. So when you think of it as one service, then it's actually easy, like it's simpler than the previous architecture. And the way this works is that the user uploads the picture, it goes to the cloud storage bucket, then this triggers an event. So in the end, like we are still dealing with events. So it's event driven. But then when this event goes to a function, that starts an orchestration. Now this goes to workflows. Now in this orchestration, workflows decides what event type this is. Is it deletion? If so, it deletes the image thumbnail and it deletes its labels and things from Firestore. Then if it's object creation, it makes a call to Vision API, transforms the data via a function, checks if it's safe, then stores the metadata, and then calls the thumbnail service and the collage service, right? So in this model, things are event-driven in the sense that an event starts our orchestration, but from then on, the workflows takes over and just makes call to things either directly or indirectly through calls to the services that do the work, okay? And let me show you this actually. So let's upload a picture. But well, before I do that, let me show you the workflows. So if I go to workflows, you can see I have this Pic-a-daily workflows defined. You can see the execution. So this is when the workflow ran. So it's very easy to see. And then you can execute it again if you like. You can look at the source. So if you look at the source, this is how things run. And you can read it, actually. You can say, okay, I received some arguments, which is the event that we're going to receive. From here, I extract the file and the bucket of the image. Then I do a switch statement, and I check if it's object creation, object deletion. If it's object creation, I go to image analysis call. So that's the next step. If it's object deletion, then I go to garbage collection, right? And if the event is not supported, then I just raise an error, right? And I can actually see this from here too. This is the switch, this is the branches. That's very useful. Then in image analysis, we make a call to Vision API. So this call is being done from workflows, not a separate service. We capture the result, then we pass it to the transform function to get what we need from the body. We check safety. So all these are again done from workflows. Then we store the metadata. Then we make calls to thumbnail and collage service. So we are calling the services that do the work. And once we are finished, we finalize and return. You can return whatever you want, but we're returning the HTTP codes from image service, metadata service, store metadata service, thumbnail and collage service, right? And again, you can see this from here, right? And the end, right? And then you can do like catches, try catches, and exceptions and things like that. So this is very useful. So let's actually upload a picture. So here I'm gonna go to, let's upload this picture and submit. So now this will trigger an event and it will trigger the workflows after that. And if we go back to our executions, you can see that there's an execution that's active. So this is running right now. And then when we click on the execution, it's still active. We can see that the input, and this is the input that it receives. So we can see the inputs. And when it's done, we're going to see the output as well, if it's successful or not in here, whatever it returns. This usually takes a few seconds, sometimes a little bit longer, depending on if services went to sleep or not. But pretty soon this should be done and it's still active. And once it's done, we'll come back here and we'll do a refresh. Yeah, actually, you can see that it's already done. So if we go to executions, I think, yeah, this succeeded. And then you can see the output as the output of 200. So it looks like everything worked. And then it's labeled and the collage is also updated, right? Yeah, so you can see that. All right. So that's what we did. And what we learned in this transformation from event-driven to orchestration is that, first of all, you've seen that in event-driven architecture, we had 3 different eventing formats. And with that, we had some complexity that was, increasing. When we switched to workflows, we said, okay, let's not deal with all these different formats. Let's just deal with simple HTTP calls. And that was quite refreshing. So we could stick with simple HTTP post requests. Of course, we had to still parse the post request body, but it was much easier to deal with than dealing with CLUD events or pops up messages or anything like that. So that was refreshing. That meant less code because with no event parsing. And we could get rid of image analysis and garbage collection functions, services, because workflows can do those for us without having to deploy new services. So overall, I think our code was less. And overall, the setup was easier because before we had to set up PubSub, we had to set up scheduler, we had to set up event arc to call our services. or to pass events to our services. Whereas in this case, we only had to define our orchestration. So we are trading complexity of 3 different services with one service that does the thing for us. And the error handling becomes really easy because when something failed, like workflows would tell us, this step failed, and you can go to that step and you're immediately scoping your debugging to that step and what happens in that step. So with that, things become really easy to track. Now, on the other hand, workflows is a new service that you have to learn, and you have to learn how to write the YAML and things, and it has some limitations. So it's not for free. It's something to learn and understand. We had this constant dilemma between code versus YAML. You could do something in workflows by writing it in YAML and making workflows do the work for us, call it like Vision API, for example. Or we could deploy a service that calls the Vision API and make workflows just call that service, right? So that's another way. Which one is the right approach? There's no right answer, but typically, if it's something small, we prefer to do it in YAML. That way, we don't have to deploy an external service and let workflows deal with it. But if it gets complicated with more logic, then we usually prefer to write the code, like, for example, creating the thumbnail or creating the collage, because code is easier to deal with. We are coders. I don't like YAML. YAML is more like configuration. So I'd rather do the things in code, test it in code, than trying to do all of that in YAML. Now, debugging testing is difficult in workflows in the sense that you cannot debug YAML and there's no local workflows runner. So you can't step through things easily. It's something that you need to learn, but we are changing that. We are actually working on a debugger for workflows. So you will be able to debug things a little bit. But as of today, local debugging and testing is limited. Whereas if you write things in code, as you know, you would be able to unit test it and run it locally better. So that might be something that affects you, which way to go versus code versus YAML. And in workflows, things happen in sequence usually. So you have steps that run sequentially. Right now, there's no parallel steps, although there's a feature that they are working on to make it possible to run steps in parallel. But as of today, it's sequential. So you have to keep that in mind. And also, you lose the flexibility of eventing. In eventing, things are really easy to plug in a new service, just deploy and configure, and that's it. Whereas in orchestration, in workflows, you need to deploy that, and you also need to change your orchestration, deploy it as well. All right, so that's it. That's all I had to share. So if you want learn more about workflows, this is the link. If you want to build this app, this is the workshop, and the code as well is on GitHub. We have these services written in multiple languages, but if you see a service that's not written in your favorite language, feel free to send us pull requests. I actually just merged a pull request from someone to have a Java version of collage service. It was written in C#, Node.js, and Go, but now we have the Java version as well. All right, so I will pause here and I will check if there's a question. I see something. So someone is asking, Rui asking, given the orchestration may depend on multiple services, who is responsible for its maintenance? Let's say you have a change in your service API and the service is used on multiple orchestrations. Are you responsible for that update? How can you discover in what orchestrations your service is currently being used? Yeah, that's a good question. So as far as the service is concerned, the service doesn't know anything about the orchestrator. The service, all it does is that it receives an HTTP request, but it doesn't really know that it's coming from workflows or it's coming from you or someone else, right? So it is your responsibility to track your orchestrations and where is that orchestration and which services that orchestration is calling from. So if there's a change in the service, you need to kind of go to your orchestration definitions and change the orchestration as well. I agree. This is not ideal because how do you know that this service changed, so I need to change this orchestration? There's no coupling between the two, but at the same time, it's also a good thing because your services can be deployed independently. They can live in different places, but they can also be called from an orchestration, right? So in that sense, it's good and bad. It's a compromise basically. But you're right. You need to think about orchestration the changes in the service causing orchestration changes is something that you need to worry about yourself. Okay, I think from what I see, that's the only question. So thanks for listening. Hopefully it was useful to you. And if you want to ask more questions, feel free either now or even after today. This is my Twitter handle. So if you want to find me on Twitter and just send me a message, that's totally cool as well. So yeah, thanks very much.
Thank you for being with us, Mete. I hope we can meet again, maybe next year in person.
Yeah, I really hope so. I love visiting Portugal, so hopefully by next year we'll be able to do that.
We need to. Thank you very much. Thank you,
thanks.
everyone.
Have a nice rest of the
Bye.
conference.
Bye. Thank you very much.